Hello everyone, welcome to Almighty Tricks. In this video, we'll be understanding about observer design pattern. We'll see 2 to 3 example to understand observer design pattern. Let's see the definition first. So the definition is saying in observer design pattern, when the state of one object is changed, all of its dependent objects are informed and updated. It maintains one-to-many relationship. Let's understand this definition with multiple examples. Let's understand first example. Say in a class, a teacher conducted a test and teacher evaluated the score of each student. Now there are two ways to publish the score, right? The first approach is teacher will call each student and update the score. Say teacher call Dheeraj and update his score. Teacher call Anil and update his score. Say in the class there are 100 students and then teacher will call 100 students and teacher will update each and every score for each student, which is not an optimal approach. Now let's see second approach. In second approach, a teacher prepare a sheet with student name and score. Then teacher will put this score sheet in the notice board and each student can check the score from the notice board. Okay, here students are observing notice board. When result sheet attached to the notice board, then they can see the score. Here students are observer. Now let's see the second example. Say Almighty Tricks is the YouTube channel and it has multiple subscribers. Now when Almighty Tricks upload a video, then its subscriber will notify the new video and that new video is uploaded by Almighty Tricks. Here subscriber are called observer or we can say subscriber and Almighty Tricks is the subject. Okay, so here also you can find there is relation like one-to-many relationship. Okay, let's see another example on e-commerce website, say Amazon. When we purchase or place order in Amazon, internally it calls email service, then SMS service, then invoice service, right? Here these services are called observer or subscriber and Amazon is called subject. Let's understand this example in detail and we do a practical with this use case. To understand observer design pattern, we need to understand why we need observer design pattern. So in this example, we are going to see what are the problems we can get if we are not using observer design pattern. And we'll see the practical example as well. First of all, I'll explain this example without observer design pattern and we'll see the practical as well. After that, we'll see what are the problems we can find in this example. And then we'll see how we can solve all these problems using observer design pattern. Let me quickly implement this Amazon's e-commerce website, which will call email service, SMS service and invoice service when a order placed in Amazon. Let me create one package observer. Let me have one file called without. Okay, let me create one Amazon class. Let me create SMS service class. Let me have email service class. I can have invoice service class and I can have one client class. In client class, I can have publish static void main. So in the Amazon class, I can have, let me write some function in the email service. Let's say okay, so I have implemented Amazon class without using observer design pattern. Let me run this code. So it is printing send email, send SMS and invoice generate. So what I did in email service, I can have one send email method and invoice service, I can have one generate invoice method. And in SMS service, I can have one send SMS service method. In Amazon class, I am using this email service, invoice service and SMS service. And I am in the Amazon constructor, I am initializing these variables. And I have one method called order place. And from the order place method, I can call those respective methods, send email method, send SMS method, generate invoice method. And from the client, I can instantiate this Amazon and Amazon class and I can call this order place. So I can get this result. So let's understand what are the problems we can have if we are not using observer design pattern in this case study. So if you see, I have this email service, SMS service, invoice service. and I have one method called order place, and from this order place method I am calling this send email, send SMS, generate invoice. Okay, and I have this send email method, send SMS method, and generate invoice method. So what are the issue we can find here? The first issue is here it is breaking dependency inversion principle. So these email service, invoice service, SMS service are tightly coupled with the Amazon class. So dependency inversion principle is breaking here. And also, let's say in future we want to use some new service like courier service. So in that case, we need to go to Amazon class, and here we need to change the code, right? So which is breaking OCP as well. Okay, so let's say another example I can say, let's say in future in email service is down and we don't want to use this email service. So in that case, we need to come to this Amazon class and we need to remove this email service class, and then we need to deploy. So which is time taking. So these are the issue we can find if we are not using observer design pattern. So this approach is breaking dependency inversion. This approach is breaking also OCP, and we need to change the code. Then we need to redeploy if we are not using observer design pattern. So to solve this issue, we need to use observer design pattern. So if we use here one interface, let's say this is our interface. Let's say some interface we have. Okay, some interface we have, and it is method, let's say order place. Okay, and this interface can be implemented from email service, from SMS service, and from invoice service. Okay, now if it is implementing this interface, then we need to override this order place method here, right? Here we need to override, here we need to override, here also we need to override. Now if we are implementing this interface, then we no need to use this email service, invoice service, and SMS service, because these are type of this interface. So let's say this interface name is order placed observer. Okay, so this interface is implemented by email service, SMS service, and invoice service. Now what I'll do, I'll not use this directly. What I can do, I can have list of order placed observer. Okay, as email service, SMS service, and invoice service are implementing this order placed observer, so I can use list of order placed observer. So observer design pattern is using one to many relationships. So if you see, we are using list, so it is satisfying the one to many relationship. Let me implement this with observer design pattern, and we'll see how observer design pattern is solving all these problems, dependency inversion problem, open close principle problems. Okay, let me create one package with, so it will include all the implementation for observer design pattern. Let me have one interface, order placed observer, and this interface will have one method, void order placed. Okay, and now let me do one thing. Let me copy all this email service, invoice service, and SMS service. Okay, so email service is having send email, invoice service is having generate invoice method, and SMS service is having send SMS method. So what I'll do, I'll need to implement order placed interface, order placed observer interface, and I need to implement the method, order placed method. And from here, what I can do, I can call directly the send SMS. Okay, similarly, I need to do same thing for invoice service. So I need to implement order placed observer. I need to override the order placed method, and I need to call the generate invoice. In the email service also, I need to implement order placed observer. I need to override the order placed method, and from here I need to call send email. Okay, now what I need to do, I need to create Amazon class, and from here what I'll do, I'll have list of order placed observer. Okay, observers, then I can have new array list. Okay, now what I need to do, I can have that method, so void place order in Amazon. Okay, now from here, whatever the services we need, those services we need to loop through, and we need to call the appropriate method. So what I'll do, I'll take for loop, then order placed observer, then order placed observers, then here I need to call observer dot order placed. Okay, so let me go to the client. Let me create one class called client, and I need to have publish static void main. I can have Amazon new Amazon class. Then what I'll do, so basically we need to have another method called add subscribers or add order placed observers. So why? Because we need to tell we need to add the subscribers or services into this list, right? So for that we need that. So public void, let's say subscribers, or maybe observer, we can tell add, let's say add observers, let's say, and here we need to have the order placed observer, and we can have order placed observer dot add and observer. And another thing, we can have another method where we can remove the observer. Let's say in future we don't want email service or SMS service, so in that case we should not come to this class or this project, and we should not change the code. Okay, so for that we can have one public void remove observer. So it can remove observer in runtime. Order placed okay, remove observer. Okay, now let me go to the client. Here maybe I can have Amazon dot add observer. Here I can have new email service, so I want email service. Okay, similarly I can have another observer, SMS service. I can have another observer, invoice service. Okay, and here I can call Amazon dot place order in Amazon. So if I run this now, it will give same thing. So why this approach is better than the previous one? Because so in the Amazon class, it is not directly associating with the email service or SMS service or invoice service. So it is associated with the interface. Okay, so it is loosely coupled now. So because of this only, it is satisfying the dependency inversion. Another issue we can solve here. So let's say in future we don't want to email service. We don't want to use email service. Let's say email service is down. So in that case, we no need to come to this code, and we no need to remove email service. So what we can do, we can use this remove observer method, and we can remove the observer. Remove the observer means this email service we can remove. We know in the runtime only we can remove. Let's say in future we need to use another service called courier service. So in that case, we no need to change any code in the existing code base. What we can do, we can have, let me create that. Let me have courier service, and in the courier service, let's say I have one method public void delivery method, and let me have one print statement delivered. Okay, and I need to implement this interface order placed observer, and I need to override that method, and I need to call delivery. Okay, so if I want to use courier service also, then in the client only, I need to add this courier service class. So by this, OCP principle is solving, and also we no need to change the code in between, and in the runtime also we can remove or add the observers. So in the runtime, let's say courier service. So we are not changing any code here. So in the client only we are adding this courier service. In the runtime we can add the courier service, and we can remove the SMS service or email service based on our requirement. So this is how we can implement the observer design pattern. Let me run this code. So if you see, we are getting send email, send SMS, invoice generate, and delivery. So when we add this courier service, we haven't changed any code. So what we did, we just implemented we have just created new class, and we have implemented this order placed observer, and in the client class just we add this courier service. So by which we are able to solve the dependency inversion and OCP principle also we are solving. And one more thing here I can do, without implementing like this, I can do one thing. I can have in email service, I can have the public email service, and here I can have Amazon. Anything is fine. So this is another way we can add the subscribers. So Amazon dot add observer, and I'll put this. Why? Because I want so what I want when I start this application, I want all my email service, SMS service, courier service, and invoice service should subscribe to or should observe this Amazon class. Okay, so that's why what I did, I have created this email service constructor, and it is a parameterized constructor, and from here I am adding the observer, and this means this email service is adding to the add observer method. Okay, let me do it in every class. Okay, now I'll go to client. In the client, what I can do, Amazon object, new Amazon, and I can use new email service. What are the services I want to use? I can use here email service dot Amazon. I'm passing the Amazon object, and similarly new SMS service, then Amazon. Similarly here new invoice service, then I'll pass Amazon. New courier service, I'll pass Amazon. Okay, now what I'll do, I'll call Amazon dot placed order in Amazon. If I run this, then it should work. Okay, so it is also working. So in this, you can use this way, or you can use this way. Anything is fine. So let me show you the diagram as well. So if you see, so we have created this order placed observer interface, and this interface is implemented by SMS service, invoice service, email service, and courier service, by this structure we are able to solve dependency inversion principle. Also we are solving open close principle. So if in future we want to remove any of the services, let's say email service we want to remove, then we can remove it in the runtime. And also if we want to add new services, let's say courier services we want to add, then in the runtime only we can add the courier service. So we no need to change any code in between. So we can do all the changes in the client. If we want to add new thing, then we need to create one class and we need to implement this order placed observer. Okay, so this is all about observer design pattern. Hope you understood all this concept. Thank you for watching this video.